Hi everyone, welcome back to another Collodion chat. So today's video is going to be a little bit different in that there's not going to be any video here of the real world. Instead, I want to do a quick little screencast to kind of demonstrate how to alter the dimensions of my 3D printed wet plate holder design to fit your camera and or plate size of your choice. Before I get into that real quick, just wanted to throw in an obligatory reminder that we are doing Florida Wet Plate Day in less than a month. It's going to be December 2nd up in Wekiwa Springs State Park, close to Orlando. So if you're anywhere nearby and you want to take part in that, it's going to be a great day. And I will leave a link to the Eventbrite page in the description. So if that sounds fun to you, it's totally free. The only thing you got to pay is, I think, $5 to get into the park. So if you're a practicing wet plate photographer, you are just interested in the process or you're learning, we'd love to see you. So sign up on the Eventbrite page and hopefully we'll see you December 2nd. And now let's get into this. So I designed this wet plate holder with the goal of to make it as easily manipulatable as possible, right? So the CAD term for this is it's a parametric design, which means the design is basically defined by a whole bunch of numbers, right? Parameters that we can edit, and then that will be updated. Those updates will be reflected in the design. So in theory, this is pretty easy. In practice, I know a lot of you aren't necessarily familiar with FreeCAD or even CAD software in general. It's totally understandable. It's not a super, intuitive UI to someone who's not used to this kind of thing. So I thought we would just take a quick tour around the design and sort of the bare minimum of things that you need to know to really quickly just update the dimensions of the plate holder to fit your desired specifications. So let's start out by opening up the 8x10 version of the plate holder. I'm just going to open our file here. And let's see what we've got, right? So most of our screen is taken up by this 3D view. And this is where we actually see the plate holder itself, right? The thing that we're working on. Now, I'm using the Linux version of FreeCAD. I'm pretty sure this is the same on Windows and Mac. But what I'm doing is I'm using my middle mouse button to kind of drag this around in 2 dimensions. And if I want to rotate it, I hold down that middle mouse button and then I click with the right mouse button and hold that down and drag to rotate the part. I can also use the number keys on the top of the keyboard to rotate through kind of all 6 different, ordinal directions to view this from different kind of predefined angles, right? So the 2 key, for instance, the 2 key is this top-down view, which is what I've mostly used while working on this thing. If you get your view like really screwed up, you kind of, and use the scroll wheel to zoom in and out. Let's say your view really screwed up, you can't see anything, hit the V key and then the F key, and it's going to kind of reset you to a view of the part. Now on the right side here, you can see that this design is split up into a bunch of different components, right? And these are all visible in this tree view. So the body bottom, for instance, is what's mostly visible here right now. If you open these up, you can see all the different steps that go into constructing them. We don't need to worry about that. What you do want to know is that these ones that are grayed out, these are hidden. And the way that you hide and unhide them, you can right click on them and, click or unclick hide. But the space bar is the quick way to hide and show these, right? So I've got the body top part here selected. I'm just going to hit space bar. You can see that comes and goes. We've got like the light trap here, right? We can see how it fits into that slot. But if I want to see the whole slot, I can just hide the light trap. There it is. So we can go ahead and just show all of our components here, right? We've also got the lid. So here's our parts. That's the 3D view. We're not necessarily going to need to use this 3D view a whole lot because basically everything that we need to edit, we should be able to edit in the dimensions file. In the dimensions spreadsheet. So that's at the top of our view here. We hit that dimensions button. That's going to open up this big old spreadsheet. Now this is opened as kind of a tab at the bottom here. So if I want to go back to my object view, I just click this tab. Dimensions is over here. Now this is, I'm not going to say this is great, right? Confession time, I learned how to 3D model explicitly to get into making 3D printed plate holders. So I have basically learned CAD and gotten a little bit better at it each time I've done an iteration of this plate holder design. So we're now on version 4, and at this point I like to think that I kind of sort of know what I'm doing for the most part. But this dimension spreadsheet is still basically the same from like the second or third version of the plate holder. I've been copying and pasting this as I go. It's accumulated a lot of cruft. So it's not necessarily going to be the friendliest thing to edit, which is kind of the reason that I felt the need to do a walkthrough of editing it. So let's see if I can explain all this. The basic thrust of this spreadsheet is that all these things on the left side here, these are different parameters that you can edit to influence the design, right? These influence all the different dimensions that went into the operations that made up this plate holder. So everything on the left here, you can edit and it will update some relevant part of the design. These things on the right are meant to be calculated, right? So if we look at the, if we click one of these and we look up here at the top, we see that this is just a number that I entered. If we click on these, we see these are all formulas. So all these things on the right here, you really don't want to edit. These are, right, these are just calculated values that I use in the design. And on the far right side, we have just some automatically generated stats. There's only one, it's the maximum plate depth. This tells you that the 8x10 holder, for instance, can theoretically fit about a 5.89 millimeter thick glass plate, which should be thicker than probably any of us are using, which is great. So let's go ahead and look at our parameters here, right? What can we edit? So the first thing we want to look at is the specifications at the top. These are the physical specifications of the size of your plate holder and the image area on the front of it, right? As well as the depth to the surface. Now for any of the standard plate holder sizes, right, as defined by, ANSI, the American Standards Organization, we can pull these from this nifty website that I found on the internet. This is like some guy's Earthlink homepage. It has since dropped off the face of the internet, but I saved an archive.org link to it, and I will leave that in the video description as well. And this is the best resource I've ever found for these dimensions. These are all pulled from the ANSI standards, but the standards themselves I found are really difficult to track down. I can't find them on the ANSI website. I can't even find a way to order them from the ANSI website. I think you have to write to them and request a physical copy. So much easier to just use the information here. And so these are the parameters that you would then enter here. Now I've also got, right, so these are kind of the theoretical dimensions, right? What we have next is the actual sizes, right? So this is going to tell us what is the actual opening in the front of the plate holder and what is the actual plate height and plate width that we want this plate holder to physically accommodate. And you can see the way that I have structured these is for the actual sizes, right? So this is an 8x10 plate holder. And what I have done here is I have I've made the plate height and width 8x10, but I've added 3/32 of an inch, which gives us just a little bit of leeway, right? So 3D printing can be slightly imprecise in extrusion, especially at corners. So you don't necessarily want this to be a super tight fit for your plate. So 3/32 of an inch I found is a pretty safe amount of leeway to leave, so that, if your printer is over extruding a tiny bit or if your pressure advance isn't tuned in just perfectly, you'll still be able to fit an 8x10 plate in here. And then we've got the exposure height and exposure width, right? These are kind of the plate height, plate width are kind of forming the outer dimension of here. Let me just go to my two, right? So if we look at this kind of shelf that the plate rests on, right? The plate height, plate width are forming the outer dimension here. The inner dimension is formed by that image height and width. And so what I usually do there, exposure height and width. What I usually do there is I subtract 6/16. I think I did some math to get that number. It basically allows you to put a slightly undersized plate in as well, right? I did that mostly for myself because I have used a lot of Chamonix plate holders that use slightly undersized plates. So I want to give this a little bit of leeway to fit those smaller plates as well. If you are using if you're using standard full-size plates, you could actually reduce that margin a little bit. But those are the kind of the key parameters that you'll probably need to edit for almost any change you'll want to make, right? You can scale this up or down. You can scale the plate size up or down. And so, that'll change the design. And then we've also got a whole bunch of other things in here, right? Things that you can tweak. There's some things that are just not even relevant anymore, right? Like foam squish is from the old version of the design that had foam backer rod. But we have things here that affect, like, for instance, how tightly the lid is going to fit, how we chamfer that. And we've got a bunch of settings down here as well for the magnets, right? Which is, how many magnets are we going to use, and so on and so forth. So here's our plate holder. And I think what I'm going to do is I'm going to answer a request that I got. So I periodically get requests from people to make custom sized versions of my plate holders. And I got a request today for an 18 by 24 centimeter plate holder. We'll call it 180 by 240. I'm just going to go off on a brief rant here. I don't like centimeters. I think they're a weird unit. Whenever I build things, I mix centimeters and millimeters. I always get the decimal places wrong. Millimeters are fine. Just use millimeters. We don't have centigrams or centiliters. We don't need centimeters. Millimeters and meters. Okay. That was completely uncalled for. Nobody wanted that, but it's fine. I've got a captive audience, whatever. So we're going to try and make an 18 by 24 or 180 by 240 plate holder. Now, from everything I've been able to find on the internet, I couldn't find any formal specifications, but from what I've read, these 180 by 240 plate holders, more common in Europe, obviously, where you're unlikely to find inch-denominated film or plates, right? These are externally the exact same dimensions as an 8x10 plate holder or an 8x10 film holder. It's only the interior that's a little bit smaller. So in this case, right, the spec up here is going to stay the same because this is just defining essentially the outer dimensions of the plate holder. But we're going to change the actual dimensions of the exposure in the plate here to properly fit. So let's go ahead and we could edit this file, except the standard 4x5, 5x7, 8x10 versions of this design are not great if you make the image area significantly smaller. The design kind of breaks down a little bit. So if you look in the printables for this, there is an experimental version for a reducing plate holder, and I'm just going to go ahead and open that up. So this is a slightly modified version of the design, and as you can see, it plays nice when you have an image area that is completely different from the outer dimensions of the plate holder. So let's take this file, and all I'm going to do is I'm going to open its dimension spreadsheet, and it's the same format as all the others. So I'm just going to go over to our 8x10 dimension spreadsheet, and I'm just going to shift select I'm going to Control C and Control V, all those dimensions over. You're going to see that this takes a couple of seconds for everything to update. And then when we go back to our view, look at that. Now it's an 8x10. So we can go ahead and close our old file, because we just care about this reducing file now. And here's what we're going to do. We're going to go to our exposure height. We're going to change that to 240 millimeters, and we'll leave in the that margin. Thankfully, the FreeCAD has no problem mixing imperial and metric measurements, as weird as it might be. And then we're looking at, what, 180 by 240, I think? Yeah, so we'll make our exposure width 180 millimeters. And now we can see that our exposure area has gotten a little bit smaller, but as we can see, our plate size is still the same. So we'll change our plate height, still keeping the same margin, but we'll use 240 millimeters for the height. And we will use 180 millimeters for the width. As you can see, it takes a while. Oh, whoops, I accidentally updated the same one. One kind of annoying thing about FreeCAD is that when you update one of these parameters, it can take a while to recalculate. If you're going to be making a bunch of changes and you don't want to have to wait every time you hit enter, you can right-click on the kind of the top level item here, and you can hit skip recomputes, and that will actually skip those updates, right? So now when I change this to 240 millimeters, you see it goes to pending, right? So now nothing is updating. So this is fine if you want to make a bunch of edits, and then you can hit Control R to manually recompute. But I'm going to leave that off in case I forget. So now let's see what's going on here. Oh, I got this wrong again. This should be 100. Or no, this is 240. Yep, I typed the wrong thing. This should be 180. And now everything's good. Excellent. So let's go back. And now what we see here is a plate holder that is the same size as an 8x10 on the outside. But on the inside, it has just the right amount of room for a 180 by 240 plate. And you can see we've got a little bit more, our kind of light trap outside on the outside of the lid here is now a little bit roomier than it used to be. So I'll show you how to export these files in just a second here. I just want to spend a second though kind of waxing poetic about reducing plate holders. I think this is one of the coolest things about 3D printing plate holders is that it allows you to, if you want, instead of making reducing frames to shoot smaller plates in a given size camera, and having, either putting a smaller back on the camera or putting frames inside the plate holders, you can just make a plate holder that is a reducing plate holder, right? That has a big external dimension and a small internal dimension. So like, let's say I wanted to make 4x5s in an 8x10 camera. I could just adjust my exposure height to be 5 inches, right? Exposure width, 4 inches, plate height, 5 inches, plate width, 4 inches, recompute that, and then boom, we've got ourselves a plate holder that will fit in an 8x10 camera, but will give us a 4x5 image with no reducing frames needed. And yeah, this is something that would be extremely silly to make, right? If you had to make a plate holder by hand out of wood, or you were setting up molds for injection molding or anything along those lines, right? It would make no sense to put that much effort into making a reducing plate holder. But the beauty of 3D printing is that you can make a reducing plate holder. It costs you a couple dollars in materials and maybe 20 or 30 minutes to put it together. As long as you've got the free printer time to print it, the printer does its thing while you're doing whatever else, right? You don't have to do anything except get the print job started. And so, yeah, this is just me being a little bit poetic, but I think reducing plate holders are really cool. I used one for a while when I was making quarter plate daguerreotypes. I just made a 4x5 holder with an exposure area for a quarter plate. It worked great. So anyways, reducing plate holders, good stuff. Highly recommend making them. Let's go ahead and update our dimensions back. And we're still skipping recomputes here, so let's change this back to 240 millimeters by 180 millimeters. Whoops. You gotta make sure you include the units or else it will be unhappy with you. 240 millimeters, 180 millimeters. We can recompute that. And that will give us our slightly reducing plate holder. So here we've got an 8x10 holder that will fit a 180 by 240 plate. So what we need to do now is take this design, and I'm just going to go ahead and save it in the same directory, but I'm just going to save it as 180 by 240. And now what we need to do is export these to STL so that we can print them. So each one of these individual parts is going to become an STL. Now to generate an STL file, we're going to need what's called a mesh, right? So these objects, or bodies as FreeCAD would call them, right? They're kind of, you can think of them as kind of perfect objects, right? These circles are perfect circles. The curves are perfect curves, right? Whereas a mesh it's kind of like a vector image versus a raster image, right? It's going to be kind of a concrete version of all these things. So what we need to do is we need to generate meshes for all of these bodies. So what I like to do is just hide all the parts so that as we create the meshes, we will see them in the 3D view. Now, FreeCAD kind of organizes its UI around workbenches, and the idea is that whichever workbench we pick, it's going to change the different features that are available to us in the user interface here. So what we want to do is go to the Mesh Design workbench, and this gives us a whole bunch of different features for manipulating meshes. Now, we don't need to worry too much about all these features. All we really need to worry about is creating and exporting the meshes. So let's take a look at creating the meshes first. We're going to go to our toolbar up here, the meshes toolbar, and we're going to hit create mesh from shape. And we've got some different options for ways to turn these bodies into meshes. I always use the standard. The default settings are generally pretty good. I'll be completely honest and say that I don't fully understand the effects of these, except that I know that smaller numbers here are going to give you a more precise fit, as in the meshes will be closer to your idealized object, whereas bigger numbers are going to allow a less precise fit. So as an example, if we crank these way, way up, right, we can see that we get kind of a weird mesh, right? It's going to have edges that are maybe a little bit segmented, right? Whereas we'll just delete those meshes and try this again. Whereas if we go with very small values, we'll say, 0.5 millimeters here and 1 degree here, we get meshes that are much, right? At this point, you can't even see kind of the individual slices here. You kind of can if you really zoom in, but it looks much smoother. So if you make those parameters very, very, very small, you'll get very, very precise fits, but you'll also get huge STL files. So usually the defaults are a little bit smaller, I find work well. Now, this is showing us our meshes, right? These are the actual STLs that we'll be exporting. And now all we have to do is right click on each part, click export mesh, and I'm going to make a little STL directory here, and I'll call this light_trap. I'm sure there's probably some way to script this export, and I really should, but I just haven't gotten around to looking into it yet. So for now, all I do is I go to each part individually and export the meshes. Top, we've got our lid, and we've got our retaining tab. And then I'll go ahead and delete those meshes. I will show our parts again, and I'll just go ahead and save that. Now, let me go ahead and show y'all what these STL files look like when I load them up in Cura. And this is just the slicer that I use for my 3D printer, which I need to update, but I haven't gotten around to yet. So we can see here, body bottom, boom. There's our reducing plate holder, and then we can slice and print that. I believe that most of these parts are gonna print in the orientation that we want them. I think the lid actually is defaulted to upside down, so I always just flip that by clicking on the surface. There we go. I should really change that orientation in the design, but I'm always too lazy to do that. And then, fun fact about the light traps. If you're printing one of these, do me a favor and try this out. So I've told people previously to print the light trap, and I've printed the light trap this way, right? With the, kind of the obvious orientation. I actually think that it might be possible and even preferable to print it in this orientation with the 45-degree angle against the build plate. I want to give that a shot because the biggest problem with this design is that when we print it in this kind of default orientation, we get layer lines along this slope, and that makes the light trap a little bit kind of jerky to insert, right? Because it catches a little bit on those layer lines. I think if you print it in this orientation, I'm pretty sure it will still work fine. You shouldn't need any supports. And that way you'll get a nice smooth surface on that surface that interfaces with the dark slide. And I think you'll probably get much smoother dark slide insertion if you print this way. So if there's anyone out there who is about to print one of these and you happen to see this, do me a favor and give that a try and let me know how it works. I think it will improve the printing experience. But anyways, you've also got the retaining tab, right? Once you've printed all your parts, you assemble it, and you're good to go. So that is my quick, or if I'm being honest, probably not so quick. I don't know what the runtime is, but I'm guessing it's longer than I wanted. But that's my guide to updating the 3D printed wet plate holder design. So feel free to hit me with questions if you have any in the comments. And if you don't, hopefully this helped you update the plate holder design to your liking. So with that, I will let you go. Thanks for tuning in, and until next time, happy shooting.